Hi everyone and welcome back to the multiples of 100 plus data science project series. In this video, we are going to discussing about the crop yield predictions using Python and machine learning. Also, we are going to be building one Flux application in order to predict the crop yield. So, बिना किसी देर के हर हर महादेव बोल के start करते हैं detail. Well, so in order to building this crop yield prediction project, you're going to use the dataset from the Kaggle that's called crop yield prediction dataset. If I go down in the data explorer sections, you can see here it having the five CSV file. So we're using here the el underscore df.csv file with having other column just like area, item, the year, and all of the necessary column I have. So this is nothing but a problem based on the machine learning, and this is also regression types of machine learning problems. Okay, so I'm simply going to select here this el underscore df and click here to download, and I will download this data set in my directory. Okay. Well, so our download is completed and we download the dataset from the Kaggle. And you can also see here the CSV file, the same name CSV file, year underscore df.csv. And also I create here one empty IP1 file. So for this case, you're going to using here the Jupyter notebook. You can also using here the PyCharm or Google Colab itself. So now what I'm going to do, I'm simply going to opening this file. This is the empty IP1 file. That is also called the Jupyter notebook kernel or Jupyter notebook editor also called. So in this editor, we try to do the coding part. And after that, when you're building the Flux application, you're going to using the VS Code. So first thing first, what I'm going to do, I'm simply going to load the dataset from a directory. You need to load the dataset from the directory, you're going to using the pandas library. So let's say import the pandas as PD. Okay, pandas as PD. Then you're also importing here the numpy for the linear algebra. So let's say import numpy as np. Then for the visualization purpose, we're using here the matplotlib. You can also using the cbird. So let's try to importing all the necessary library. So let's say import import cbon as sns. Then also import matplotlib dot pyplot as plt, just like that. Now I'm simply going to add here one style so that our graphs looks cool. So let's say plt dot style dot use, simply going to using here the gg float. Okay, gg float like this way. Okay, थोड़ा mistake हो गया यहाँ पर bracket के issue. Okay, fine now. Now it will importing all the necessary library in my Jupyter Notebook kernel. I mean Jupyter Notebook editor. Now what I can do, I'm simply going to load here the data set from my working directory. So make sure that your data set file, I mean the CSV file should be in the same directory. So I'm going to using here the pd.read underscore csv, and inside that I'm going to giving here my file name. So call yield underscore df.csv. Okay. Now let us store it inside the variable called df. I mean data frame. Okay, let's say df.head. It will show me the data frame in the form, the data in the form of the data frame. I mean the pandas data frame. See it having a named 0, the area, the items, the year, the hgh yield, and average rainfall millimeter per year, the pesticide tons, and also the average temperatures. So now the question is it a supervised machine learning problems or a unsupervised machine learning problems? So in my case, the question answered is nothing but called supervised machine learning problem. And also, what kind of problem is it? Is it a regression problem or a classification problem? See, when it is a classification problem, that's mean it nothing but having some category, just like the yes or no, or one or two, or just like one, two, three, like this way. But if you see, we need to predict here this hg underscore h yield. So this is nothing but some continuous types of value. Continuous types of value. That's mean this is not the categorical types of value. I mean not in the form of the category, right? Yes or no, or dog or cat, just like that. If it's a dog or cat or just like where, this is called the classification task. If it is a form of the continuous types of value, this is called the regression problem. That's why this the problem is nothing but a regression types of machine learning problems. And also this is supervised machine learning problem, not unsupervised. Okay, fine. Now what I can do, we define here that which kind of problem is it. Okay, now it's easy to choose one machine learning algorithm. But before that, we need to also clean our data. We need to clean our data. See, in our data, unnamed 0 is not necessary. We can simply drop it out. So what I can do, you can using here df.drop, and inside this drop we can keep here our data frame, I mean our column name, and inside this axis, which axis we're going to drop in from the column, we're going to drop all of them and simply going to make it in place equal to 2. In place equal to, let's make it true, and let assign it to variable. You can assign to the same variable, or otherwise you can shift enter. it will affect in your whole data frame. If I see that df.head, then you can see it will affect it in our whole data frame. Cool. Now let's try to checking here information regarding our data. So let's say df.info. So you can checking the information regarding your data set. See, in your data frame, it's having right now the 7 columns: area, item, year, hg underscore ha, yield, average rainfall, millimeter per years, pesticide tons, average temperature. See, it just having the 2 columns is nothing but from the string. I mean, you could say also the categorical value. Okay, it's available inside the area and item, and all of the things are now converted into integer or the float. That's mean we don't need to handling this out. Yes, we can do here the standardizer in this uh, 4 or 5, yeah, 5 columns, and rest of them we can do the one hot encoding. I just talking about the data pre-processing tasks. So now let's try to checking here, is there any null value inside of a data set? So let's say df.isNull dot sum. Okay, so I see there is no nothing about the null value in our data set, so we don't need to handle this out. Now let's check in this, is there any duplicate value or not? Because in duplicate values is actually making some noise in our data and try to behind it, try to build in the machine learning problems model, it will give me the wrong answers. So that's why I need also checking that the duplicated value. So duplicated dot sum. Okay, just like that, duplicated. Okay, duplicated is nothing but itself a method. Okay, it having some duplicate value. So what you can do, you can simply go into dropping this out. Okay, so let's say df dot drop. Okay, drop duplicated. So duplicated. Okay, duplicates, not duplicated, duplicate, and we're simply going to making this implicitly true so that it's not changing the data set. Okay, entire data set. So let's make it implicitly true. So true like this way. Okay, so we right now we drop all the duplicated value from a data set. So let's try to check this side right now. Now you can see it having 0 duplicated value. That's really fine. That's really fine. Now let's try to checking the shape of my data. So let's say shape. This shape is look like that. So let's try to also check here our descriptive analysis of the data set called description or describe. Okay, this is describe our data set. I mean the count, the mean, the standard deviations, the minimum, 25% percentile, 50%, 75%, and also the maximum values. Okay, this is our descriptive value. I mean the description regarding our data set. So you can also checking that the correlation between my data. So df.core. Okay, this is the correlations between my data set, how the data is correlated with each others. See, when you actually using a df.correlations, the categorical value, I mean categorical types of columns is not visible. I mean area and items. That's mean correlation is happening in the numerical types of value. Okay, in the numerical types of value. Now, what I can do, we can also check that. Let's try to do some data visualizations. Right? Let's try to do some data visualization. Okay, or you can also say that EDA, exploded data analysis. Okay, let's try to do some data visualization of data, that how our data actually look like. Then we go further for the machine learning models. Right, cool. Now let's try to checking the length of my df of my area. I mean how many country or location are available inside my data set. So we can using here the unique. Okay, unique, and let's try to check this out. Okay, it having the 101 area. I mean 101 types of country is available inside my data set. Okay, you can also checking this way. You can also checking item also, and let's try to check the item. Okay, 10 item that you already know that in our data set when I download the data set from the Kaggle. Well, so now let's try to do the plotting part here. So let's try to do the plot so that it look better. And even we actually import here the matplotlib and seaborn, but we don't use it. So why should we import it, right? So let's start using here the plt.figure, figure, just giving him one fixed size. So let's say fixed size, and try to using here the 15 comma 10. And after that, you can using here the, yes, you can using the count plot. Let's say sns.count plot, and inside this count plot, or we can using here y equal to df of just like area. Okay, I mean how many countries are available, plt dot show. Okay, so you can also using here just like country map to show all the country in a map. Okay, थोड़ा छोटा हो गया ना. Let's try to make it 20. Okay, now it looks good. You can see Albania, Algeria, Angola, Argentina, Australia, Azerbaijan, the Bangladesh, Belgium, Brazil. Let's try to checking for India also. Yeah, here is India. Then Italy, Malaysia. Okay, all of the things: Sri Lanka, Spain, South Africa, Uganda. Okay, Ukraine, the United Kingdom, the Zambia, Zimbabwe. Okay, all the countries available in my data set. Okay, now you can also checking that checking also the area count. I mean the area. So what you can do, you can also do the same thing for the item also. So let's try to do it for the item. So let's try to do the for items. Okay, okay, this is the item, how the items look like. So we see that the most of the items is nothing but called the potatoes. Okay, potatoes actually yield in most of the countries. Okay, so what you can do, you can also check that the value count of the area, that how many value count are available, just like greater than 500, you can checking this out. Okay, so let's say df, what I'm talking about, let's see if the area. Okay, if the area, the value count of the area is greater than 500. I mean, because it having, let's say, in our data set you can see it having so many country name: Albania, 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 Albania again. Okay, I just need to checking that if the area of the value uh, count is nothing but, let's say, value count. Okay, value counts is nothing but greater than 400. Okay, just need to do on sum. Okay, just need to do on sum. Let's try to check that how many country available. We can see it having the Brazil's, Pakistan. Okay, it's making it false. It's boundary method. So let's say area dot value counts, if it is greater than 1, so we can simply go to making a sum. Okay, now it's a it's less than, if it's less than 400, having the 88 country is available in my data set. Just having look the data, that how the data look like, and if there any value is less than 400, which how many country is available in that. Okay, so you can check that how many country is actually uh, cultivate the potatoes. You can also checking this way. Okay, now let also checking this way. I mean, how many countries or how many yield are actually available in the per country. Okay, so let's start making the country. So country equal to, let's make in df of area. Okay, dot unique, so that you can get here the unique value, unique country name. Then after that, I'm going to using here, let's say, for a state in country. Okay, just going to checking that uh, I mean, based on this value, if I go down up, see, this is nothing but about target columns. This is nothing but about target column, hg slash ha yield. I mean, how many yield are available per country? In the per country, how many yield are available in the per country? Let's say Albania, 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 Albania. So what you can do, we're simply going to join all of them and try to count the full area, full yield area of the country. Okay, just does it, this is something we call the data preprocessing, right? So let's try to do that. So what I can do, we can, let's get here one uh, empty list called yield per country. Okay, per country, let's make it empty list, and inside this list we're simply going to add here all of the things. Let's get append. Okay, and after that I'm simply going to make it, let's say, df of area. Okay, df of area, yeah, df of area is nothing but equal to state, is equal to a state. Then after that we just need to checking which one, we just need to checking which columns, based on the which columns, based on my target columns. Okay, based on my target column. Okay, then after that what I can do, I simply going to do the summation of that. So let's sum. Okay, now if I try to checking here the df of hg slash ha. Okay, dot sum, then what to get, we got here some kind of numbers. If I'm using here the same things called yield per country, then you can see, okay, per country, it having 100, yeah, 101 country. Based on the whole country, it will creating here how many yield is available inside the per country, in the per country. You can also calculate this kind of way. This is nothing but called the, this is not going to call, this is not going to call that how many yield are available in the per country. So you can also plotting this out, you can also plotting this out. So you can using here plt dot figures, just having looked at how many plot are yield are available, I mean mostly available in my, in the data set, okay. So you can using here for the y, you can using here the country. So which country you can use, we can using here the, this country, and in the x-axis we can using here the yield per country. So you can copy this one because it having all the values, okay, yeah, per country, that's it. So if I show this one, let's try to do the count plot, the bar plot. Yeah, let's try to using, okay, I need to using the bar plot because count plot is just taking one numbers. In bar plot you can give here two things, okay. So if I see in the India, it having most yield, it having the most yield rather than other countries. And in the second, it having the Brazil's having the most yield, then the Australia, then Japan, and also having the Mexico, and also having the Pakistan, the Spain, the Turkey, United Kingdom. Let's see the Bangladesh. Oh, thoda thoda. Okay, this is Bangladesh. Argentina also having the most yield in the per country. So this is how you can checking that in which country it having the most yield. So if it have the most yield, so you can do more crop. You can cultivate more crops. Okay, this is just nothing but just have a see that about the data, okay. So now what I can do, you can also checking this yield based on the item, okay, based on the items, just like we see this. So what I can do is simply going to copy this out for do the same thing for the based on the items. So you can simply going to pass it here and just going to making the items, and in order to using here the in yield per country, you can using here yield per crop, and you can just copy this out and we're simply going to pass it out here, and paste the country, we're simply going to using here the crop. Okay, let's making crop, and let's making crops, and let's make it crop, and based on the item, right, not area. So item, we're going to checking here the crop, and we based on our target columns. Okay, cool. So shift enter. So now you can simply going to using the same things, going to copy this out, and I'm going to paste it here, and instead of country you're going to using the crops, and after that yield per crop, that's it. Fine. Now you can see again the potatoes is cultivated more uh, than the other crops. So well, so this is our data preprocessing task, and you also see that the yield per country and also yield per item. So in this case, we see that India is having the most yield, and also potatoes is the most cultivated crop in the each country. So now what I can do is simply going to jump our next topic, the important topic that's called building a machine learning model. But before that, we need to also divide our data set into train, test, and split, and also dependent and independent features. But before that, we need to also check that is there any categorical value is available in our data set. So if I go down, you can see it having the area and the item is nothing but in the form of category. That's like the country name and also the item name. Now we're using here the one hot encoding to making this one in the form of numerical. Okay, that's means 0 or 1, 2, 3 like that. And also in the year to average temperature, it's nothing but in the form of the numerical. So you're also handling this numerical value also. Now the question is, sir, why should you need to handle the numerical value? Because this value is not in a standard form or the normalized form. Due to making this data in the form of the normalizations, I mean standardizations, we can using here this tactic. But sir, if I try to using here the same technique, each of the columns, each of the columns, it will take much more amount of time. Let's say I am going to convert in this area, then items, then year again, then this one, this one, this one, this one. It will take much more amount of time, even though taking long types of code you need to write. Now, in order to removing these things, or in order to removing this problem, what I can do, we can using here another new technique. It's called the column transformers. Column transformers. Actually, creating this series because of creating just not only the existing, not only the exciting products, but also learning some new technique also. That's why I creating this multiverse of 100 plus data science product series. Okay. Now, what I can do, we simply going to making our data set. I just need to change this data set in the form of this where so that I can using this data based on my column index. Based on my column index. Now let's see what I'm talking about here. So let's try to checking the df.unique value. Okay. So okay, data of columns. Okay. So UMS columns. So columns, yeah, columns like that. Okay. Now simply what I can do, I simply going to using here the columns, and after that I'm simply going to copy all of the columns from here. So let's say copy this one. Okay, copy this one, and after that I'm going to changing this something on that. Let's say this is my area and the items. So what I can do, I am simply going to cut this one and paste it here. Paste it here. Now why I paste it here? And again, this is my target columns, and I'm going to cut this one and I'm going to paste it here. Now, sir, the question is, why should you making these changes on your data set? Why should you making changes on your data set? Why? See, how are you using the column transformer? Column transformer means you creating one pipelines. In the pipeline, you can also do the missing value imputations. You can also do the normalizations. You can also do the one-hot encoding. That's in a single transformer, you can do all of the tasks. All of the tasks. So what I can do, we can taking the value based on my column name, based on my column name. Now, sir, if you giving here the column number index, I mean 0, 1, 2, so why should you change this one? Because I don't need to change this one, because I change it based on my um, I mean what is saying in English, subida. Okay, subida ke liye maine is tarah kiya, right? Okay, now what I can do, I can using here the df. Let's say df, and I'm going to using here the df of column. Just going to change in this data set based on my column. That's a df.head now. Okay. Now you can see this is our data set. How our data set look like. Here, average rainfall, all the things, and hg slash yield is nothing but my target column. So what I can do, we can divide our data set in the train test bit. So let's say x, but before that, it's also making this in the dependent and independent field. So let's say y and x. So let's say df, and from the df, which one is my target column? This is my hg yield, and rest of them is nothing but in my x. So what I can do, you can using here the drop, and inside is just dropping here one column. So let's say hg, this one. Okay, and inside that I'm going to making here x is equal to 1. Okay, x is equal to 1. See, if I go up, you can see the same dropping technique that you're actually using here. How you need dropping here the unnamed one. Okay, the same things you can see in place equal to true. You can also make in yourself, but it's not necessary. Okay. Okay, now it's available inside my same directory, so we can also removing this one also. Okay, so if there are any problems, yeah, hghl not found in my axis. What's the problem is here? Okay, it should be the x is equal to 1. Now it should be found. Okay, fine. Let's say x dot shape, the shape of my data. If I see the y dot shape, this is the shape of the y. Fine. This is how we divide our data set into dependent and independent features. Now, what I can do, we divide our data set into train, test, and split. So for that, you can import it here from scikit-learn. Let's say from scikit-learn dot model selections. So model selection. You can also using the tab key from your keyboard to getting the auto suggestions. And I'm going to importing here the train, test, and split. And I'm going to using here the train test split, to divide our data set into train, test, and split for 80% for the training and 20% for the testing purpose. So let's using here the train, test, and split, and inside it I'm going to passing here x and y, Then let's giving here the test size. So test size is nothing but 0.8. Then random state is nothing but called 0, and let's call shuffle equal to, let's make it true. Now let's divide, let's assign to the variable called xtrain ytrain, xtrain and ytrain, xtrain xtest, okay, and ytrain ytest, like this way. ओके एक्सपेक्टेड इंडेंट, थोड़ा मिस्टेक वहाँ पर हो गया है शायद. ओके ट्रेन टेस्ट एंड डिस्प्ले रैंडम स्टेट शफल इक्वल टू, बट व्हाट कैन ए प्रॉब्लम विद इट. ओके एक्स ट्रेन एक्स टेस्ट वाई ट्रेन वाई टेस्ट, या हियर विद इट. इतना मिस्टेक हो जाता है, थोड़ा पानी पी लेते हैं इसलिए बेटर होगा. Okay, that's fine now. So now what I can do is simply going to converting our categorical data to the numericals, and also do the scaling of our data. I mean, do the one hot encoding. Now, how can I do this in a single lines of code? Okay, in a single lines of code, it's also called the pipelines. But before that, it's also importing in all the necessary library, right? So let's say from scikit-learn dot pre-processing. I am simply going to importing here, let's say one hot encoding. Then from scikit-learn dot compass, I am simply going to compose, not compose, compose. I'm going to importing here the column transformers. Okay, column transformers. Then also importing here the standardizations. Let's say from scikit-learn dot pre-processing, I'm simply going to using here the standardizations. So let's say standard scalars. Then I'm simply going to creating here an instance of the one hot encoding. Let's go one hot encoding. Let's call the one hot encoder and try to make it drop equal to first. Okay, drop equal to first. And after that, I'm simply going to also creating the instance of the scale. Let's call the scale. It's called the scaling. Call the standard scalars. Also called the normalizations. Okay. Now we're simply going to creating here the preprocessor now. It's nothing. Preprocessor is nothing but call preprocessing, nothing but call the pipeline. You can also say that just like the pipelines. So see what kind of pipeline you can create. Let's say column transformers, and inside this column transformers, I'm going to giving him a transformer name. So let's say transformer. Okay, transformers, and I'm giving the transformers in the based on my dictionary format. But before then, it also giving here the reminder. थोड़ा reminder भी दे देते हैं यहाँ पर. So which kind of reminder? So let's say reminder equal to let's say pass through. Okay, pass through. THROUZH. Okay, GH. Pass through. And now the main things is coming up on the scene. Okay, so first thing what I can do is simply going to do the standard scalar. Which column one? 0, 1, 2, 3. Okay, 0, 1, 2, 3. Then which one we need to go the 100 encoding? 4 and 5. This is the target column. You can see using the same technique here. Which column you're going to do the standard scalars? 0, 1, 2, 3, okay, 4, 5. Okay, like this way. Let's say because it is quite noisy when you actually selecting here your column names. Let's say 0, 1, 0, 0, 1, 2. Okay, 3, 4, 5, 6. Okay, it having 6 columns. So which one is go for the standard colors? Standard means the numerical value one. Numerical value is nothing but called 0. Not 0 is going inside my categorical value. That's been 100 encoding. 0 and 1 is going inside my 100 encoding, and 2, 4, 5, and the 6 is going inside my standard color. But when you actually making this data set in a quite balanced things in the form of the dependent independent features, just like the target class is nothing but in the last of the columns. This is right now the quite interesting. So for selecting here the value in the standard colors. Now let's see what I'm actually talking about here. So let's say making one name called the standard color. So let's also pass it inside the bracket. So we call the standard scale. Okay, so what I can do, we can give pass here my value called, I mean the instance of that scale. Then inside that, now you need to passing here your index number 0, 1, 2, 3. So 0, 1, 2, 3 is nothing but my index number. 0, 1, 2, 3. But when you're choosing this 0, 1, 2, 3 value from here, it is quite mismatch. Quite mismatch. That's why I renaming this one based on my subida, right? Okay. So now what I can do is simply going to using here another technique called the one hot encoding, because this is a categorical value. So let's go one hot one. Okay, one hot encoding. So let's call encode, and then we're going to passing here oh he, then which 4 and 5, not 6. Okay, that's fine now. So we can shift enter. Okay, expanded called reminder or reminders shayad. Okay, reminder. Okay, let's inside this transformers column transformer, it having the scale value. Is there any problems in my data scale? Okay, I think, and it's also giving here uh here. Okay, reminder. Okay, so it's not remainder, reminders. Okay, like this way. Again, reminder. What a mistake हो जाता है यहाँ पर. Okay, it's called a remainder. Okay, fine. Now what I can do, now we can actually do this, apply this preprocessor inside my X train and the Y train. So you can using here the preprocessor dot feed transform. Okay, transform inside my X train and also my X test also. Let's copy this out and paste it here. It's called the X test. So what I can do, we can actually using here the X, okay, not this one. We can using here the X train, let's say dummy. Okay, and let's copy this one also, and okay, and I'm going to making this one X test dummy. Okay, you can also pass it into the same variable name also. So if I try to checking the preprocessor the features name, we can also get the feature name also. So let the get features name out. So you can get in the features name based on my columns name. So let's taking all of the things from there and rest of the last name. So this is how the 100 encoding is applying inside the Angola, the Australia. So the for the area, it will actually using the 100 encoding, and for the average temperature, it actually using the standard scalars. This is how the column transform actually work. It will actually help you uh, to do the same things in the pipeline. You don't need to actually using here the scale standard scalar in the each of the columns. This is how actually using the column transformer to getting all the standard scale value and to fit it inside your data set. Now what I can do is simply going to train our model using some machine learning model also from the scikit-learn. So what I can do, you can actually input it. Let's say from sklearn dot linear model. So linear model, I'm simply going to using here the linear regressions because this is the regression types of machine learning problems. Then let's using here another technique called lasso. Okay, lasso. Then also it having the rich. Okay, rich. Okay, thoda rich. Okay, then from the neighbors, you're going to using the k neighbors classifier, not classifier, k neighbors regressors. So from sklearn dot neighbors, we're simply going to using here the k neighbors uh, transformer classifier regressor. Fine. Then we can using here the decision tree regressors. So from sklearn dot tree, we can simply use here the decision tree regressor. Okay, decision tree regressors. Okay, let's try to also import the error also. So let's say from sklearn dot metrics, and I'm going to importing here the mean absolute error, and then also the R2 error. Okay, fine. Now let's create here one model list in the from a dictionaries. Let's make it models. So let's say first one is called linear regressions. So linear regressions. Okay, we can using the let's say linear regression, create one instance of that. Then we have the lasso. Let's take in the lasso also. Then what we have the reach. Let's say reach. Let's start using here the reach regressions. Okay, reach. Then what we have the decision tree. Let's say decision tree. Okay, so we can using here the decision tree regressors. So we can also using this can neighbor regression also. So let's start also using this one. So let's say canon. Okay, can neighbor regressor. Okay, fine. Okay, so that's our model is ready. Now what I can do is simply going to iterate to all the value from here. Let's say for in models, okay, models dot items. Okay, items. So these items actually give me one name and another is nothing but call the model name. So let's call MD. Fine. Now what I can do is simply going to using here our data. So let's call MD dot feed, and you can using here our xtrain dummy, then also our xtest dummy. Okay, xtest or y10, sorry, not xtest, because this is testing data. Okay, now for that you can get here on predictions. So let's make it md dot predict, and we can passing here my xtest dummy. Okay, not sami by dummy. Okay, so let's make it y predictions. Okay, we can also now printing here your mean absolute error and also the R2 score error. So let's start printing here. We're also using the accuracy or score also. Let's call accuracy score. Okay, so let's try to printing here the accuracy score, and inside this accuracy score you can using here the y test and the y predictions. Okay, it will give me the accuracy score. Then we can printing here the R2 mean absolute error, then also the R2 score. That's it. Shift enter. Okay, thoda error. Classification metric cannot handle the mix of multi-class and continuous target. Why this error is coming up here? Xtrain dummy and y-train, and xtest and y-test dummy. Okay, let's try to shift enter here again. Classification matrix cannot handle a mix of multi-class and continuous target. Why is error? Okay, let's try to removing this one now. Okay, now it will give me the values. So I think so we can removing this accuracy score. Yeah, now it's fine. Without accuracy score, we can actually see here our mean absolute error and also the RTF score, because accuracy score is not for the multi-class classification, just for the regression scores. So that's why it's not working. Okay, so what I can do, we can also printing this one in just using the format specifier. You can actually using this one. That's F, and we can using here the name of a classifier. It's called mean absolute error. Mean absolute error is nothing but in here. Let's call mean absolute error. We copy this out and paste it here. And after that, what we have the score. It's nothing but in the R2 score. Okay, we copy this out and paste it. We can remove in this. Okay, shift enter. Now for the linear regressions, you can see here all of the errors. So if I see the lowest error is available inside my decision tree classifier, and can also having the lowest one, but not more than the decision tree. So what I can do, we can simply going to save our model. So which model you're going to select here from the decision from above the model, we can select here the decision tree. So what I can do, let's say DTR equal to decision tree regressor, and after that you can using here DTR dot fit. So you can using the xtrain dummy, I mean the same thing, xtrain dummy and the y-train, and after that you can using here the predict one. So instead of MD we can using here the DTR. So DTR, fine. Okay, that's our model file now. So now what I can do is simply going to creating here our predictive systems and try to getting the value from our data sets. Okay, that's our model is ready. So let's try to building one predictive system. That's it. Okay, so in order to creating here one predictive system, so what I can do, we can using here one functions that's called predictions. So which one taking the year, then it will taking the average rainfall. Which one? So you can using here one thing. Let's call a df dot columns. Okay, year the average rainfall millimeter per year, then paste it as ton, then we have the average temperature, then we have the area, then we have the item. Okay, we have the item. That's it, all of the things here. Then what I can do is simply going to using here np.array, and inside that we're simply going to pass all of the value. We're simply going to pass all of the value and try to making this data set should be the object, and we can simply going to copy this out. I'm just going to making this in the from the array, and after that what I can do is simply going to making this data type d type in the from object. Okay, fine. Now this is nothing but a features columns. Okay, this is nothing but a features. So features, okay, features. That's it. Now we need to also transform our features because we're using the preprocessor, I mean the column transformers, just like the standard scalars and also the one-hot encoding. So that's why I need to using the preprocessor dot transform. Okay, transform, not feed transforms. So it's going to passing here my features, and this feature actually give me one output. That's called the transform features. So transform, that's underscore features like this one. Then what I can do now using our decision declassifier to do the predictions. Let's say dtr dot predict, and inside that you can passing here my transform features name, and after that we're simply going to reshape it. So reshape it in the from a -1 to 1, and this is give me one predictions. So that's called the predicted yield. Okay, that's it. Okay, now we're simply going to return here. So return here the predicted yield, now this one predicted yield. Okay, so 0 and 0. That's it. Now what I can do, I need to pass here all the value inside my prediction functions. Let's kind of copy this one, and inside this function it will give me one result. So let's say result like this one. Now what I can do, I need to giving here some values. So let's say let's take in some value from here. Let's try to using here some value. So df dot, let's say head. So we can copy the value from here. Okay, copy the value from here and paste it here. Okay, this value, this one, let's say this one, and also this one, and this is the target one, right? Just you need to predict it, and also this one, and try to make it inside the string. Okay, so let's make it a string Albania. I'm going to cut this one and trying to pass it here, and instead of image I'm going to pass it here and paste it here. This give me the result. Well, so now what I can do is simply going to printing here our result. So we're simply going to copy this for result and try to paste here and shift enter. Then you can see we got here one wrong predictions. Based on my input, I can get here 36613, but I got here 14871. That's been the wrong predictions. So let's see what error we actually do here. Yeah, here is what. Okay, you can see the test size is nothing but the 20%. So you give here the 80%. That's why it's occurred types of value we can got. So let's try to using the shift enter now and try to waiting for the result. So it will do the predictions, I mean predicting here the models, and after that we can get here our prediction results. So let's wait for a few seconds. या थोड़ा थोड़ा मिस्टेक हो जाता है यहाँ पर. So instead of using the train size, I can using the test size of the 80%. So that's why I got the wrong result. So if I go down now, yeah, you can see here right now I got here the correct result, 36613. That's mean our model is working really very fine. It's working really very fine. So now what I can do is simply going to save this file inside of a directory in the form of the pickle format. So what I can do, we can simply going to import here the pickle. So let's say import here the pickle. Here is it. Let's import pickle. Then I can using the pickle dot dump. Then inside that I can passing here my DTR and using the open method. And after that I can using here my model name. So my model name is called DTR dot pickle file. Okay, dot pickle file. Then after that I need to also saving here the preprocessor, because preprocessor is needed. If I see in my predictive system model, you can see preprocessor is needed. So you need to also using here this dump and try to using here the preprocessor dot open, and you need to also giving here the mode. So in the which mode I am going to using it, what in the read write mode. Okay, so let's make it in the WB, and also the same thing here WB. And now let's try to make this DTR with the preprocessor.pickle file and shift enter. So now let's see inside my directory. You can see inside my directory, you can see here the preprocessor.pickle file is generated. Okay. Okay. Preprocessor.pickle file is generated. You can see preprocessor. Okay. So if I see inside my directory, if I see here, yep, here it is. You can see here dtr.pickle file and also preprocessor.pickle file is generated in my directory. Now what I can do is simply going to creating here on web applications and try to take in this value, just like the year, the average rainfall, millimeter per years, pasteurized stones, the average temperature, area, and also the items. And after that, we can simply go into creating here application and try to uh, get here the predictive values based on the columns. So we can using the flux. Okay. Now what I can do, we simply going to go on our VS Code and try to check that how can I creating the web applications for the crop yield predictions. So this is the UI for crop yield prediction per country. So here you can see some text box which can take in the input from the users, just like year, the average rainfall, the pasteurized in the tons, and average temperature, and also item and the area. So when the user clicking this predict button, it will give me the predictions based on the input of the users. So now what I can do, this is the code for that. That how can you building the Flux applications. So see, first thing first, we create here one template folder, and inside this template folder, you having on index.html file. So here we having all of the design in the bootstrap format. See, it is simple, just like it's just having one container, and inside this container is just having one text that's called the crop yield prediction per country, and just having one input all featured here, just like you can see inside my application. You can see crop yield prediction per country and input all the featured here. Then we have some text box which are taking the input from the users, and which having the name of the years. You can say name of the years, name of the average rainfall, name of the pasteurized tons, the average temperatures, and also the area, and also the item. Just simple things called MD6. Okay, inside this six, just having the 6 rows. Okay, 6 columns. Inside this, we have the labels of the years, just having the name of the years, and value is started for the 2023. Okay, 2013. Okay, just one simple column for that. Simple. From then we can add here one button for predictions. Okay, and button type is nothing but submit, just like that. Then you have the predictions. If the prediction is coming up from our app.py code, and then it will give me the prediction score. Okay, now let's go inside my app.py, which one is really important. Okay, so first thing first, you import the flux and import the flux and request and also the render tablet, because you need to render the template from our templates folder. It's called index.html. Then you also import here the numpy and import the pkl, because we have the safe model file in our folder that you can see, dtr.pickle file and preprocessor.pickle file. Then we have the scikit-learn from import scikit-learn. Then we simply going to load here our model in the RB mode. Then also import here, load here the preprocessor file. Then simply going to creating here an app equal to flux underscore name. Then this is the first initial route. So when the application is loaded, it will showing this kind of interface that you see. Okay, then when the user fill up all of the value from here, and click on the predict button, it will go this value inside our if predictions. Okay, this block, this Jinja template block. Then what I can do is simply going to create here one route for predict. If I go inside this index.html, and inside that you can see type is nothing but submit for the predictions, and also you can see this is nothing but on forms, so an action is nothing but the slash predict. That's been when you clicking this predict button, it will go inside this form, and the action is nothing but the predict. That means this slash predict is nothing but one route of my Flux applications. That's mean it will go inside this Flux predict, and method is nothing but post. Method is nothing but two types of method you can actually initialize. One is called the get method, when you're getting the data from the database, that's called the get method. And post is nothing but when you're trying to post something on your databases. Okay, on the model, and model give you the answer. Okay, or the request. So you can also see here, action is nothing but predict, and method is nothing but a post method. So the method is nothing but a post. So what I can do, you can simply going to take in the input from the users request from. So request dot from, we're taking this input based on my name field on my text box. If I see that, you can see this is nothing but called name equal to year. Based on that value, it will take in the input. Then also for the average rainfall, the prestige size in the tons, also average temperature, area, item, the features. Okay, now what is the feature actually? So if you see inside this crop el prediction file, then you can see one thing. This is nothing but my Jupyter notebook file. So if I see the features is nothing but when actually creating the predictive model, you can see feature is nothing but getting all the data and simply going to pass it inside one numpy array, because we need to convert this data into numpy array for the single predictions that you do on here. We're simply going to convert them into np.arrays. The simple, we're using the preprocessor.transform and pass the features, and also reshape it -1 to 1. Okay, that you do also here. Okay, that we do also here. You can see the reshaping the data. Then we're simply going to return here the predicted yield. That's it. And simply going to render in the template the index, and inside the predictions we're going to passing here my predictions in a 001 00. Okay, now this prediction output is passing inside my random template by the Jinja template. Okay, by the Jinja form. So you can see here in my index.html, there is a thing that's called the if the prediction is happening, I mean if there is any prediction value, it will taking the text, it will taking the predictions from the from our app.py, and it will store it inside the prediction value, and it will show it in your UI. Okay, this is how the Flux application is created. So now what I can do, we simply going to test it out. So in order to testing this out, we can simply going to run it out from here, and it will opening this link in a local host, just like the 127.0.0.1. Okay, this is the link. Okay, if it appear, if I click here the follow link, now you can see the application is open. Okay, so you can see year is nothing but 2013, and let's say average rainfall. So let's go on here and try to check that some value from here. Let's say this one. So what I can do, we simply going to using this one. So first one is nothing but call a year, but it's better we can go on here and taking this input from here. Let's try to taking this input one. Year is nothing but this one. Okay, and we're simply going to pass it here. Okay, then which one, this is called nothing but call the average rainfall in a millimeter. So you can taking this one. Let's taking this one and precise in a ton, let's say 121. Let's get this one, and average temperature is nothing but call 16.37. So we can copy this one, and let's say 16.37. And let's say area is nothing but one name. So let's using this one mesh for the item, and the area is nothing but, let's say call Zimbabwe. Okay, let's click on predict now. Okay, please enter the value. The two nearest value are 16 and 17. Okay, average temperature, let's make it 16. Okay, so you can see predicted EL value is right now 16,246. Okay, this is how your application actually work and give you the prediction value. Okay, and you also test it out here. You can see for 190, and this one you can actually test it out already. Okay, so this is how our full application process is actually work. It will give me the prediction value. So you can also give me some value, just like average rainfall, let's say 455, prestige let's say 2121, point let's say 97, and let's say give it here, let's say 355. Okay, temperature, average temperature is not should be like that. Let's say average temperature, let's say 20, and let's say area, let's say call Bangladesh. Okay, let's say item is, let's say maize or potato, or let's say rice. Okay, I don't think the rice is available inside my data set. If I go inside here, yeah, rice is here. Okay, okay, rice is here. So if I click at predict, okay, value should be entered, value nearest should be okay. You need to give here the value in the form of the integers. So let's remove this one and click at predict. Okay, rice is the column is during the transformations. Okay, rice is not available. It's a rice is not available in our items. Okay, let's try to using the potatoes. Okay, so what you can do, you can just back here and let's go on the full screen mode, and item is nothing but let's call potatoes. Okay, click here the predict. Okay, you can see here the values. Okay, this is how the full application actually work for the crop yield predictions. You can also get here and the data set and try to explore in this data set more. Okay, so that's it for today. Now hope you enjoyed studio, and make sure to subscribe to the channels and don't forget to hit the bell icon, and I'll be back with another tutorial. So till then, take care and bye bye.